Okay, so let's do a consumer choice problem where a consumer has a choice between two goods, taro, which happens to cost $4 per pound, and nori, which happens to cost $2 per pound. And some more information is up here. So here we have the prices of the $4 per pound and the $2 per pound. And then also up here, we have the margin utilities for the different levels of taro over here on the left part of the table, right? So see the pounds of nori go from 1, 2, 3, 4, 1 to 5. And the different amounts of margin utility that the person gets at the different levels of utility. You can see that as they consume more taro, they get less utility, less additional utility. So the margin utility is decreasing. And then here in this column, we have margin utility per dollar, right? So it's margin utility of taro divided by the price of taro. Again, the price of taro is 4. So this column here is essentially taking this column, the margin utility column, and dividing by 4. So 20 divided by 4 is 5, 16 divided by 4 is 4, and so on and so forth. 4 divided by 4 is 1. So these are all the margin utilities per dollar for the different levels of taro, right? Different number of pounds of taro that the consumer would be buying. And then over here on the right, we have similar information for nori, right? So again, pounds of nori going from 1 to 5. The margin utilities starting at 8 for the first pound, going down to one marginal utility for the 5th pound, and then the margin utilities per dollar calculated here, again taking this column, the margin utilities column, and dividing by the price of nori, which is $2 per pound, right? So that's how we get these 4, 3, 2, 1, and 1/2 there, essentially dividing this column by 2, right? Okay, so the way to analyze this problem and to figure out which different combinations of taro and nori this person should buy, given the information, given their preferences represented by the margin utilities and also the prices, is that there's 2 rules that we follow, right? The 2 rules that we talked about in class, and they are that first, so the 2 conditions, the 2 rules that we follow are that the margin utilities per dollar are equal to each other, right? So the margin utility of taro divided by the price of taro is equal to the margin utility per dollar for nori. So the margin utility for nori divided by the price of nori. And doing that ensures that they couldn't switch and say buy less nori and more taro and get more utility. If this is true, then that means that they're optimizing, that they can't get more utility by substituting one for the other. And then the second condition is of course, that they should be spending all their money, right? So spending equals income. Obviously, if they have money and all they care about is consuming these 2 goods, taro and nori, then if they spent some more money and bought some more of either type of good, then they can get more utility. So the second condition is just that their spending equals their income, right? Okay, so you may have noticed that in this table, I've circled, and they're color-coded, a few different pairs, 4 different pairs of these margin utility per dollar calculations. And you'll notice that the ones that are circled red, that's where the margin utility per dollar is 4, right? So this first condition is satisfied at 2 pounds of taro, where the margin utility per dollar is 4, and 1 pound of nori, where the margin utility per dollar is also 4. So that satisfies the first condition, and then we need to ask ourselves, okay, well, they're optimizing in terms of setting the margin utility per dollar equal to each other, but are they maximizing their utility subject to their income? Well, no, because at this combination of 2 pounds of taro and 1 pound of nori, if you calculate how much their spending is, well, the 2 pounds of taro, since taro is $4 per pound, that means that that's $8 worth of spending on taro. And then nori is only $1 a pound, so 1 pound of nori costs $2. Add that to the $8, so the $2 spending on nori plus the $8 spending on taro. So the total spending at this red combination of the taro and nori is only $10. And we're assuming that this person has $22 worth of income, right? So we want spending equal to $22. But at that red combination where taro is 2 pounds and nori is 1 pound, that's not true. So obviously they need to spend some more money, right? So they need to spend some more money. So let's consider the next highest level combination of these two goods, and where margin utility per dollars, where the margin utilities per dollar are equal to each other, and that's here, and the indicated by the blue circles, right? The numbers that are circled blue. We see that the margin utility per dollar at 3 pounds of taro is the same as at 2 pounds of nori, right? So they're getting three utils per dollar at 2 pounds of nori and 3 utils per dollar at 3 pounds of taro. So again, that satisfies the first condition that we want for this consumer optimization problem. But again, if you add up their spending, well, they're buying 1 more pound of taro, so that's an additional $2, and 1 more pound of nori, so that's an additional $4. So in total, they're spending $6 more. So spending is $16. So they still have some more money to spend. So obviously, that's not maximizing their utility as well. So that bundle, 3 pounds of taro and 2 pounds of nori, is not optimal either. Moving beyond that, well, if let's consider this next bundle, and we see that when there's when the margin utility per dollar is 2 over here at 3 pounds of nori, it's the same as the margin utility over here at 4 pounds of taro, right? So both of them have 2 utils per dollar, right? So that would be another possible bundle where this first condition is true, right? That the margin utilities per dollar between the two goods are equal to each other. Okay, so we know the first condition is true at the because of the orange, the margin utilities per dollar are equal to each other. And then adding up the spending, well, again, they're buying 1 more pound of taro and 1 more pound of nori than in that blue bundle, which means they're spending $6 more because nori costs 2 and taro costs 4. So they're spending $6 more. So that means the total spending is $22. And again, their income is $22. So yeah, they would be spending all of their income. So both conditions would be satisfied, right? We have that the margin utilities per dollar are equal to each other, so that satisfies the first condition. And then the second condition is that spending equals income, and spending does indeed equal income. And just to double check, if it's 4 pounds of taro, and the price of taro is 4 pounds per dollar, or yeah, it's $4 per pound, then that means they're spending $16 for the taro, and they're buying 3 pounds of nori. Nori costs $2 per pound. So 3 times 2, that's $6 per pound. So $16 spent on taro, $6 spent on nori. That adds up to $22. So yes, they would be spending all their money. And what that means is that we know that this next bundle where margin utility per dollar between the two goods is equal to each other, they'd be spending too much money. They don't have enough money to get down to the pink bundle that's indicated here, where the margin utility per dollar is equal. So even though this first condition would be true at the pink bundle, where there's 5 pounds of taro and 4 pounds of nori, if you add up their spending, it would be $28, which is more than their income. So unfortunately for that person, they won't be able to get there, right? So it must be the case that the optimal bundle is 4 pounds of taro and 3 pounds of nori, right? Okay, thank you for watching.